Companies looking to make predictions require vast amounts of data, complex calculations, and rapid responses. Join us as we talk to Liftigniter about how they built a machine learning platform on this episode of Stack Chat. Thanks for joining us. Tell us a little bit more about Liftigniter and how you built your platform.
Thanks for having me. Liftigniter is a real-time personalization platform powered by machine learning models running in the cloud. By real-time, we mean end-to-end latency in the order of about 100 to 150 milliseconds, and this includes the network latency as well. Now, this is a real challenge both in terms of scale and computation, because we track a number of signals by users in order to provide them with the most relevant and personalized recommendations. Our worldview is that each person is unique, and at every moment in time, our platform is optimized for the most relevant results based on all the signals we gather up until that point.
Can you show us the architecture you built to keep this moving?
Sure. As an ML company that crunches and stores huge volumes of data, infrastructure cost has a large impact on our business. We focused on three main factors: pricing, latency, and reliability, just like anyone else. To emphasize these, we used three main techniques. Autoscaling based on workload lets us make sure that we have the flexibility to scale out heavy workloads on demand. And we use a combination of autoscale groups either for preemptible instances and for on-demand. Which leads us to the second point, which is the flexibility to allow us to use preemptible instances as needed. And thirdly, the option to move stale but useful data into cold storage, again for cost reduction. When it comes to speed, network latency usually has a huge part to play, but Google's network has been pretty snappy in our experience. We have been able to keep components that chatter a lot close by within the same region with enough redundancy. With Google's footprint, we're able to create and run services closer to the edge so that all the customer-facing services perform really well. And we've also been able to avoid any outages that will affect our SLA thanks to Google Cloud.
Can you tell us a little bit more about how the recommendation system was actually built?
Sure. The diagram is actually a simplified architecture diagram. We are not showing the load balancer and proxies and things like those, but it just focuses on the main components and the services that we have in our architecture. The requests to our cloud are either going to hit the front-end APIs or what we call as the model servers. The model servers are the ones which, for anything that has got to do with user activity and returning recommendation results, that's taken care of by the model servers, where all the magic happens. For everything else, like for example, updating or creating new inventory items or making other API calls, will actually hit our front-end services. Now, looking at the front-end services, when an API call comes in, a bunch of processing happens on those front-end machines, and the front-end services, they push the data into data storage. We create either files or other data, push it into some data storage like Google Cloud Storage. We also have other data stores. And GCS would actually trigger an event into Cloud PubSub where we have a lot of subscribers listening on messages on those topics. And a subscriber could pick up those, do further processing, and an example shown in the diagram is where we have an inventory system which does further analysis and processing based on what the trigger is. The model servers are the ones, like I said before, which handle all of recommendations and the user activity tracking. They do a lot of processing in-house, a lot of magic happens here, a lot of heavy lifting happens here, pushes the data once again into data storage. A similar mechanism happens, which triggers an event into Cloud PubSub, and we have subscribers listening on those topics which pick the data from GCS, do further processing. And as shown in the diagram, this data is now pushed real-time into BigQuery, where our dashboards are fed off of BigQuery for analytics. The key thing here is, while we can move things into BigQuery in real time, BigQuery can also get a little expensive. So we want to keep access to BigQuery only when we really need it. So we have an offline processing which takes data off of BigQuery, does further aggregation, pushes into Cloud SQL, which acts like a caching layer. So the dashboards would either hit Cloud SQL or BigQuery depending on how far back in time they want to go and gather data. The box at the bottom shows our Spark cluster, which runs off of Cloud Dataproc. The Spark cluster is basically used for tuning our models and retraining it for better accuracy. We run it on a nightly basis. We gather all the data from GCS. We have the models running all over again. And if the results of those models with the tuned parameters are better than what it was before, we make the necessary changes and push those configurations into the cloud.
Now, it's been a while since you architected this originally. If you could go back and do it again, what would you do differently?
We started architecting our platform around 2013, 2014, when machine learning was still not hot. Big data was still the thing of the day. It wasn't as hot or widely available as it is today. If we had all the libraries and frameworks that are available today, back then some of the build versus buy decisions would have been different. We also enable augmented intelligence by giving our users the ability to influence recommendations. Sometimes they may implement rules that can get a bit too restrictive and end up returning less results. To help enable the customization for these users, we've been researching indexing solutions to give better results. Part of this was investigating something like Elasticsearch, which was good, but it wasn't performing as fast as we needed because of our really tight latency requirements. We're currently looking into other ways to build this and keep serving improved recommendations.
Thanks so much for sharing the details.
My pleasure.
If you'd like to try setting up PubSub notifications for Google Cloud Storage yourself, check out the walkthrough in the description below. Thanks for watching, and make sure to subscribe for more great Google Cloud Platform content. We'll see you next time on Stack Chat.